Okay, so let's get going. We're coming to our week 12. This will be basically the last lecture day. So from Friday on, so Friday, next Wednesday, and next Friday, we're just going to be having exercises. So this will be the last piece of content that you'll ever be hearing me talking about here for this course. Okay? Great. So just a quick reminder. Well, actually, let me give the reminder later once we have more people in. So today we're going to be, actually, it's not week 11, is it? No, it's not week 11. Let me fix that. Well, I won't fix this one. This is the copy. So anyway, this is week 12, okay? So we're going to be talking about collections here. Collections. Collection. What kind of other collections we have seen before? We have seen some collections before. We have seen actually one type of collection before, which was a very basic, very primitive. Who recalls that kind of collection? What was that collection? That we could aggregate more than one object, more than one number. Which one? Array. So array was so far the only type of collection that we have seen. But there are several limitations to what an array can do and how effective it can be. So there are quite a lot of options when it comes to working with collections that are better than array. Better, why better? Well, better in the sense of array, to find an item, you have to run from top to bottom. You have to run through the array from top to bottom. On the types of collections that we're going to be talking about today, we're going to very quickly be able to find, search, locate an item in a collection. You're going to be able to sort things much faster, much easier. And there are a lot of different types of collections in C#. We're going to be basically dealing with two new types. I'm going to introduce a few other, but coding, really, I will only focus on two types of collections. One is a list, the other one is a dictionary. And actually, even more specific to dictionary, it's a sortable dictionary. We're going to get there. So again, objective of today, we're going to be getting to know how to use modern collections. Array is not modern. Array is old-fashioned. And we're going to be talking about that in a second. But again, it's very basic, it's very primitive. So out there in the market, people don't deal too much with arrays unless, and I'll not spoil the surprise. So one of the objectives as well of using collections is to be able to search through data collections more easily. Okay? Again, so easy to search in collections. And the other thing that we're going to be seeing today is how we can modify a collection, how we can add more items, how we can remove items from a collection, how we can change items in a collection. Okay? Why is that important for us to discuss this? Well, here's the thing. Out there in the market, you're going to be dealing with data sets. You're going to be dealing with more than one piece of information at a time. You're going to be asked to order the list of employees. You're going to be asked to tell me which employee is the one that missed the most, that has the most absence in the company. So you're going to be having to manipulate sets of data, and collections will help you to get there, will help you to manipulate data. Okay, so again, a lot of what we do as coders is manipulating data, searching, modifying, accessing, and collections is a collection of data. So again, it's important, trust me. Okay, so as you have mentioned, we have dealt with arrays before. But there is one limitation about arrays that is one of the advantages of dealing with the modern types of collections that we're going to be talking about today. Who can tell me, think about arrays and who can tell me what is one very basic limitation of arrays? Value types. Well, you have to describe value types for collections as well. So, yeah, so it's not that, actually, the fact that array is a type safe, that you have to define the type, is actually a good thing, and that carries on to collections as well. So it's not that limitation yet. Let's think a little bit more of arrays. Size of the array. The limitation, the big limitation is really because before you can start using an array, you have to know how big is the array. But then, what if you don't know how big is the array? I go back to the assignments that we didn't know. I mean, some people in the assignment said, okay, the array has 29 items. Well, there are 29 tweets. Yeah, good. I mean, good guessing. You know? But again, by using arrays, you could not. Sorry, by using an array, you have to give to the array how big it would be. But I didn't read the file yet. How do I know that? So again, we can solve that. That's fine. But it's a big limitation because the only way that you can increase an array is if you do some additional code in there. However, by dealing with collections, the ones that we're going to be dealing today, you're going to be able to add items to the collections dynamically without caring about how big it can be, because the collections will expand automatically for us. That's the reason why, again, arrays, they're simple, they're fast, but they're limited. There is a use for them if you know how big the size of whatever you're dealing with is. Array could be an option. But even so, I would question a little bit about the use of arrays.
So in the industry, like currently, they don't really use arrays, you're saying? Or is it more like leaning towards the collection?
It's more towards collection because there's so many more features and many more features that can be used with collections. I mean, one of the things that I mentioned, to find an item in an array, you have to loop through the array. You have to code that. You have to go for each, and then you have to compare. Oh, I got the one. Great, so now display. With collections, we can apply certain rules that we can say, hey, give me item, associated with John. And then it will search for me. I don't need to loop through the collection. I can loop through if I need to, but if it's indexed properly, and we're going to be talking about index and keys, we don't have to. In one line of code, we can find what we are looking for. That's it. So again, it's really an advantage of using collections. There are so many types of collections, but again, we're going to be talking about basically two types. Okay, so let's start with list. List is the natural replacement of an array. You declare a list using this syntax. It's a little bit of a strange syntax, but I think that we saw this before. The way we declare a list is that we have to indicate what type will be inside that list. And that's the reason why you have this T here. T is indicating what type. Is that a list of integers? Is that a list of strings? So we replace T by int, by string, by double. And that's how you can declare that. The same way as you declare, you declare list, and then you put the type here. You create by setting equals to new list string, and then you have the parentheses there. Again, the only strange thing here and new to us is this syntax here, that we use the less than and greater than sign with the type in the middle to indicate what type of list you are building. So when you see this kind of syntax, we're talking about generics. List here is a generic because we can create a list of any type. That's where the generic comes from. T is for type. So you have to define which type of list is that you're creating. And by type is, you have to define what is the type of the items inside your list. And again, it's a list of generics. You define here the type for the list. You need to use, to be able to use list, you need to use system.collections.generic. That's the only namespace that you're going to be using that's used for lists and for the other one that we're going to be seeing, which is dictionary. So, yeah, so that's basically it. Let's have a look at a very simple example here. This is how we declare a list of strings. So, again, I know that's a list of strings. I put string, the type, inside the brackets there, the greater than, less than, greater than. Then we specify the name, and then we say new list. We repeat the type, which our type is list of strings, and then we use the parentheses, which is, we know that's how we create a class, we create an object from a class. So again, this is our type, and we're creating a new object of that type. We didn't have to define how big it is at any point here. And then we can start adding items. So item is our variable, and I can just say add red. I'm sending a string because it's a list of strings. If it was a list of integers, I would have to add integers. If it was a list of students, of objects, I would have to add a type that matches whatever is the type here. And there are so many methods, so many properties that we can use from a list. I'm using here the add. Add will add to the very end of the list. So to add to the very end. Insert, I can say in which position I want to insert that item. Insert does not replace the item in that position, but it opens, like in this case here, we have added red. It's the first item right now. And then we are adding, we are inserting on the 0 position. Again, this is a 0-based collection. So the first item has the index 0. So we are adding in the first position yellow. But we're not replacing what is there. What is happening is that we are opening a slot there, and then red becomes the second one. And we are inserting yellow in the first position. Okay? So again, we have add, insert, we have remove, have a bunch of methods that we're going to be looking at in a second. And then I can loop through the items. I can loop through them. I just declared here a string called colors, and I can say for each string item, I'm calling the string item. In items is the collection. Do this, just loop through, and return the item for me. So I'm returning a string, and I'm just adding, accumulating here inside colors. Okay, very simple syntax. Anything does not look, I guess that's straightforward there. I mean, any questions about the syntax there? Seems.
So yellow is in the first position now, and red is in the second.
Mm-hmm. Yes. So insert is really opening a new slot there and moving whatever is below that one position.
And that color thing, it has to be a string, has to be the same as a list, right?
You mean this one here?
The colors.
The color, well, colors here, I'm just accumulating, I'm just concatenating the colors here. So I'm just, yeah, exactly. I'm just iterating through the list. It's returning item by item after each loop. So it returns the color and it returns the string. And then I'm just accumulating that inside colors. A very, very simple example of when we want to iterate through lists. Again, very simple syntax. Let's have a look at this app here. All the demonstration apps that I'll be showing here, they are already available on eCentennial. So if you go to your eCentennial on week 12, you're going to see the PDF here. You're going to see, well, this is the exercise for tomorrow, end of the day, today or tomorrow, not tomorrow, Friday. And then we have code and figures. So code and figures, you're going to have 3 projects there. Those are the projects that I will be showing as I go through the content today. Okay, so you can download from there. And we have, as usual, we have additional links here related to collections, including the YouTube video. So again, use that for a reference. Actually, by the way, this chapter is not in the book. Okay, so you do have to follow those links to get to the content, because it's not present in the book, but it is present in our course outline. Okay, so let's have a look at this application here, this demo application. I'm gonna just, and as I said, I won't be, I saw a lot of console-based applications. I said, not gonna show console anymore. I'm gonna convert those applications to Windows applications. I'm not gonna show black screens anymore. So we have a simulation of a black screen. This is great. So what do we have here? Very simple. We have a text box, which I set up a few properties on that text box. So it's a modified text box. I'm going to tell you what I did. One thing, because I want to break lines in this text box, so I've set up to accept returns. This return means the enter key. So I set it up to true, so we can have multi-lines. What else I did here? I'm showing scroll bars. So again, in a text box, if there is more content around, you can show scroll bars. So I've set up this property called scroll bar here. So I'm showing both. Let me drag this a little bit. So, where is the scroll bar? So as I was saying, I'm showing both scroll bars, and you can select. By default, it's none. And I set up the fields as read-only because I don't want to type inside. I'm just setting it up to read-only. And I'm also setting it up to multi-line, so we can type in multiple lines. So again, it's just a text box, but with a few properties being set up to make it look like that. And we have a button. That's it. So in this process button, what I'm doing is it's a similar example as the one that I just did. I'm creating a list of items, and I'm showing a few properties of items. Items has a property called count, which shows the number of items in that list, in that collection. And it has another property called capacity. Capacity is how many items right now, in this moment, is allocated to that list. And I'm going to explain in a second what that means.
Is that a keyword?
What is that? Those are properties. So again, you see item is a list string, a list of strings, and then item count. Count is a property. Again, there are no no parentheses, means it's a property, okay? So count is the current number of items in that list. And capacity, I'm going to explain a little bit better in a second, but it's how many items it can add right now without having to grow. I'm going to explain that in a second. And then, next 2 lines, I'm adding red and I'm adding yellow. And I'm using the text box to show that. So the text box there is just a way to output some information about what we're doing. So again, text box is starting with, before adding items, show the count, show capacity. After adding 2 items, show the count again, show capacity again. Let's have a look. What I did here is I put a return right there so I don't go forward with the code. I'm going to move that forward as we go along, but right now the code is stopping right here. As you can see, everything after that is grayed out, which means that they will not run. And that's my intention. I just want to run the code up to here, and then I will be expanding that. Let's see how this will run. Okay, so we have our window there. I'm going to click the button, and then we have, again, I should have tried, let me try to make this font a little bit bigger. Again, we know we can change properties of our controls in our property window. So I'm going to try to make this bigger. Okay, good. So 2 lines that I wrote there. The first one, before adding to the items collection, count is 0, capacity is 0. After adding 2 elements, count becomes 2, and capacity becomes 4. So, but Ederson, you told us that there's no size for lists, for collections. And right now I see a capacity of 4. But this is automated. This is automatically. As I add more items to the collection, that capacity will grow automatically. And the reason is that when you declare a list, C# and the OS, it needs to allocate memory to that list. Initially, because there are no items, the capacity is 0. It doesn't need any memory there. However, after we add 1 item, the capacity goes right away to 4. So it's like the memory has allocated 4 slots if I add 1 item. If I add 2, it's still 4, because 4 slots is just what I need for 2 items. If I add 3 items, 4 is still okay. If I add 4 items, still, I think, yeah, if I add 4 items, still okay. However, when I'm going to add my 5th one, that capacity will double automatically. So every time that we reach capacity, the size of the collection doubles automatically. And that means there is double memory that is being allocated for that variable right at that moment. Go ahead, Chip.
So it would go like 4, 8, 16.
Yes, it keeps doubling like that. It goes like that. As soon as we reach as soon as we try to add 1 more item that goes beyond the current capacity, the capacity doubles. That becomes a little bit tricky because, I mean, all of a sudden, if I have, again, I didn't do the math, but just imagine this. If I have 1,000 items and 1,000 is the limit, which will not be if we keep doubling like that. But let's just say, and I add 1 more, and if it doubles, I'm going to have 2,000, but I just need 1,001. So again, we have some extra.
Okay, so what happens if I have 2 count and 4 capacity, and the next step I'm going to add 6 more?
So it will automatically grow double. It will automatically double the capacity there.
Doesn't make sense for me. I mean, no, you're.
I get it.
That doesn't make sense. If you tell me that count 2 elements and capacity is 4 because each element have an index, for instance, 0 is red, 1 is yellow, then it's 4, so I got it. It's exponential.
Mm-hmm.
Otherwise, I have no idea how it works.
I mean, your question is why doubling?
Yeah, but if it's doubling,
Yep.
because each item, that capacity is space in the memory to assign an index inside the list, like 0, red, 1, yellow, 2, whatever. That makes sense for me. If you say that, and then I tell you right now, the next step is going to be 6 more elements, but I only have 2 more there in capacity, and he's going to rise again in a different number, doesn't make sense for me. I'm just saying that.
Got it.
So doesn't that like take up like space?
Yes, it does, and there's a way to fix that, and there's a way to address that. So again, it does the doubling, but there is a method that we can call, that we can say, hey, you know what? I don't want to double just because you went 1 up. I want to trim things. So there is a method that you're going to be able to trim that excess that you don't need. You're going to get there in a second. Okay, so let's see here. Okay, so I'm going to move this a little bit below and expose a little bit more code here. So here's what we're doing next. Oh, by the way, this beginning that you see here, this strange character, this is just an enter. This is just a line feed and carriage return. Okay, so it's just to break the line and go to the next line. And this $sign, who knows what that $sign does? Who has heard about interpolation? String interpolation. That?
Well, like, this allows you to like put certain like you can like instead of using like the 0,
Yep.
the 1, the 2, you can just put it directly in.
Yep, it is. So interpolation is this. Instead of putting, like Shane was saying there, instead of putting, brackets 0, brackets 1 to replace the variables, we can put the variables right there and then. We can just say bracket item count. I'm calling a variable inside the string because I'm putting it inside brackets. It will do.
What would be the preferred method? Because that's how we used to do it when I was in the Rangers class also. The other way, so is it just like what you're comfortable with type of thing?
I would say that what you're comfortable with, but I would also say that the interpolation method is more clear. Because if I just put a 0 here, and then I have to go to the very end of the string to figure out what is that 0. But what if I have 10 what if I have 10 parameters that I have 0 up to 9, and then I don't know which I have to figure out and go to the end to figure out which argument is going to that position. So in a way, interpolation like this makes things much clearer. What is it that you want to go in that slot? So it's a mix of what I would prefer, but again, it makes it more clear as well. So, so here's what we're doing now. We're going to go display a message where it says display list contents with a loop. So you're going to loop through. So you can still loop through with this kind of for. You can go from the item 0, from item index 0 to item index count -1. So you can access the items by index as well. You can still access them by index. You can access in a for each loop, but you can access in a with the index as well. So again, I'm just displaying the items there. Let's process that. So as you can see, we show the capacity there. And then we show display list contents with controlled loop, yellow and red. Yellow being the first one, red being the second one. But again, we can also do the other type of loop. We can do a for each loop, you see? We can do a for each, string items in items, and then we do this, a similar loop, but we don't use the index. We use just the for each loop. Again, similar result. You're going to have just a list of contents using the for each statement, yellow and red. So far, any questions about that code that we are starting to unveil there? I mean, any question, anything blurry there? Okay. Okay, so let's add a few more items here. Let's add green. Let's add yellow again. It's yellow again, isn't it? Because yellow was here, yeah. So again, if we are using add, we are adding to the end of the list. And we're going to go and loop through it once again. So let's have a look there. So now, after we add two more items, you see, count is 4, capacity is still 4, because it didn't have to increase capacity. And here is our list. A little bit more here. Let's try to remove yellow. Here's the thing. One note to make about lists is that lists can have duplication. That's the reason why we have been able to add yellow for a second time. However, the next type of collection that we're going to be talking about, it does not allow duplication for the keys. But again, a list does allow duplication. Okay, so again, now we're gonna remove the first yellow, because that's what remove does, and we're gonna loop through again. So as you can see, remove first instance of yellow. Now we have just 3 items. We have red, green, and yellow. The first one was removed by the use of remove. Now you see, remove, we didn't have to say the index for that item to be removed. The list went automatically to and found that item and removed the first one. And I think that there might be some, actually it does remove just the first one. So, okay, so after remove, we add them. Now we can also use something like remove at to remove that particular index. So when we remove index 1, which item in the list are we removing? The second one. So again, it's 0 based, okay? So now we are removing the first item, and then we are looping through again, and then doing a few more loops. And again, it's more of the same. Let's run until the end here. So what it does is removes from the first one, prints them again, after remove 2 elements. So again, we printed again a message because we have removed one right here, removed another one right here, and then this line in particular, it's showing if it contains, you see, contains is another method of the items. Contains is a method that returns a Boolean, it returns a true or false. Does the list contain a one with red? If yes, yeah. If yes, don't show anything. If no, add not here. You know. So we are using the other way here. We are using the not the interpolation but the replacement here. So again, one more method that we can use contain. Contain. If you give an argument to contain, it will return true or false. Is that item present in the list? Yes or no? And then we are adding a few more colors here. And then after adding 3 more elements, the count is so and so, and the capacity is so. Let's just run this here. So again, it's just a piece of code that is exploring the different methods of lists. So red is in the list. After adding 3 more elements, the count is 5, the capacity is 8. So again, it needed to expand beyond the capacity of 4, so it went straight to 8. Let me show you another method here. Before it does the count and capacity, I'm going to do this. See, there's this method called trimAccess, which is supposed to get rid of the excessive capacity there, the capacity that is not being utilized. So let's have a look. What is that? Should be. I'm not sure. Yeah. Now I'd be curious to see if we add 3 again. Yeah, it should. Yeah, I'm quite sure that it will just keep doubling from 4 to 8 to 16 and so on. Okay, so again, just a few methods that we are exploring from the list.
Access should be like a default function in the code.
It's already been called already?
I mean, it should be like a default stuff that you don't have to write because it doesn't make sense not doing that.
But here's the thing. Maybe imagine that you are in a loop, that you are adding 1 item at a time. So yes, 1 item, the first item that goes beyond 1,000, and let's think about 1,000 because it makes sense to trim 1,000. The first item that goes beyond 1,000, it doubles right away. So that the next ones, you don't have to resize, because here's the thing, there's processing time
Okay,
in the
it's
resizing
time.
process.
Is to say
There's processing time, yes, as well. So again, you may need that extra, you may not. If you don't need, you can trim it. But the point is that the code doesn't know whether or not you're going to need or not, because you are not adding, you can. But in our case here, we're not adding a bunch at the same time. We're adding one at a time. So the code doesn't know if there is another one to be added next, you know. But I see your point. You have a good point there. If there was no cost for that increase, it would make sense to do it automatically. But there is a cost. So it's a balance between how much memory you're going to allocate at a time and what is the processing cost of keeping doing that, you know, keep growing that. Okay, so this is just a list with properties, methods. So we're going to be exploring some of them, not all of them. Not going to go one by one. We have seen add, we have seen count, we have seen trim access, we have seen remove, we have seen insert, we have seen remove at. There's a clear capacity as well. We have seen that you can clear all items from the list. We have seen contain. So again, this is just for your reference. Any questions?
when you clear the list, the capacity.
Most likely it goes to 0 again. But to be honest, I didn't try that. But it could be a good test to do. But most likely it should go to 0.
I was just going to ask, like, say like the capacity doubles to 8.
Yep.
Because you went over, so you have like 9 elements, but then you remove 2, so you're back to 7. Or like you go back to like 3. Would the capacity resize back to 4? Or would just keep the memory out?
I think it will resize. But let's try that. Let's give it a try. I think it's good to find out. So in this case here, I'm not going to trim the excess. So right now, if we run this, so we have count 5, capacity 8. Let's remove 2 to go. Let's remove 1 just to go to 4. So let's say that we're going to use the remove. Let's remove one of the colors here. Let's remove blue. So again, we add 3, it grew, and then we remove 1. Let's see if it goes back to the old capacity. It does not. So let's remove 2.
Because we can reach 4.
No, but I think, but 4 should be okay.
Makes sense.
4 should be okay. Let's remove another one here. Let's remove 2. And yeah, so we have to reset. We have to trim it to reset.
You already cleared just to check.
What is that?
Clear, just to check.
Okay, good one. That's right. So clear. Let's have a look. Ooh. But again, I mean, I could assume that, hey, you don't know, the code doesn't know what you're going to do. So again, very easily you can just call. So again, trim access seems to be a very useful method.
But the application is considering that we're going to keep using stuff and probably we're going to need, again, those 8 positions.
That would be the logic. That would be the logic of it, Okay. So let's have a look at this. Now, I want to show this video because what we have seen so far with the list was with a very basic type with string. But again, we can use lists with complex objects as well. Complex objects like the ones that we have been created, like student, employee, and so many others. So I want to show this video. I think it's relevant. There is something that is not super relevant, but I think that overall it's a good video to show. In any case, as we know, it auto-resizes, it doubles capacity as it's required, and a performance tip, as we have seen, you can use trim access to get rid of the extra memory that's been allocated if you don't need to, if you don't need that memory. Let's have a look at this video here.
Learn how to work with a list of objects. I'm going to go ahead and create a brand new project, and we'll just call it list students. And I'll click OK. And remember, it's just like an array list, but with the list data structure, you
So ignore for a second what he mentions about array lists, okay? The key focus here is really just the list. Again, just ignore for a second. We're not going to be talking. Again, there are many types of collections, and we need to focus on some. And I have focused on what I judge are the most useful ones. So again, ignore the array list that he mentions.
specify the data type. Let's create a brand new class. Right now, click on that project, add class. We'll call it student. And I'll come over here and add a public string name and a public double GPA and a public string get data, which will simply just do a return of the student name concatenated with has a GPA of and concatenated with this dot GPA.
Just for a quick note, I mean, something here that I do not promote is what he's doing here. I mean, can anyone point me to what is not necessarily in line with what we have been doing? Okay, so what is this right here? Public fields. So those are public fields. So again, usually fields, we keep them private. We expose them via properties. So again, just to make it easy for him, he's just making the fields public right away, and they are behaving like a property. But again, so ideally you'd create these, but privately as fields, and then you create public properties. Or you could just go and make these auto-implemented properties. You could do that as well. But again, this way here, I don't really like that. But anyway, because those are fields. Those are not properties.
If you look quickly, that look property, because it's
If you have fields,
Yep.
private fields, and then you assign a property for
Yep.
each, can we still inside the method use this?
You can.
Okay.
You can.
Yeah, I thought it was a property when I first looked at it too, because the capitals are.
Yeah. But so again, he's mixing up here naming terminology, okay? But the point that I want to demonstrate is more of the use of a class in the context of a list. You had another point there? Yeah. So again, it hurts a little bit of what we have discussed so much here, but ignore certain things, for the sake of.
This method, when you call it, will return a string, which is that string, and there's two instance variables associated with the class. Everything's public. That's fine. Let's come back over to the program, and now I want to create a list of objects. So I type in the word list, and this is where you put the data type. We're not making ints, we're not making strings, we're making student objects. So you just specify the class name. And then I'll call it LST students equals new list. Once again, you specify the data type, and then you put a constructor. This will now go create a variable called LST student.
What's up?
What was the data type for students?
The data type for students. Students is a new class. So the data type is student.
I mean, it's not a string, it's not boolean, it's not int.
No, because remember that types, we have those primitive types like integers, strings, booleans, and so on. But type, we can define our own types. We can create our own classes. That's what we have been doing since the very beginning of what we have been talking about when we start talking about classes and objects. So again, when we create a class students, we create our own class, our own type. When you hear the word class, it means type. It's a type that we're creating. Okay? So again, we can, instead of being a primitive, we can use our more advanced classes. That's we're going to be using that quite a lot.
Students, which will be a list of type student objects. Now all I have to do is simply use my list dot add and create a brand new student object in it. And you do that by calling the constructor. List students, go access the first element, change the name, Donald. Now this is different compared to the array list because the array list is not type safe. You didn't specify the data type. The list, you do specify the data type. If this was an array list, you would have to do this. AL students bracket 0, and then you'd have to come out here and say, there's going to be a student object.
It's not relevant.
Action structure. It's a lot more efficient. I could create another object. I'm just going to copy and paste. And we'll say an object 1. Let's go put.
So I just want to highlight that he's adding, you see, the add that he's using, he's adding a brand new student. He's not adding a variable. He's just create, hey, this is a list of students. So each item in my list will be a new student. So he's just saying, hey, add to the list of students, add a new student. And remember, what new student will do? It will return a new student to that position. Which position? Position index 0, the first one in the list. And then, after that, he is manipulating the properties of this new student via the index in the list. Index 0 means position 1. And then I can say the name of the student because, remember, see, when I use the index here, this is a student. It's one student. And then I can use the properties, the methods of a student. I can call that because, again, if I use the index, it means that I'm returning the item in that position. We have a list of students, so item 0 will return a student. And again, we can use the properties and methods. And here, he adds another one. New students. Now it will be added in position in position 2, which is index 1. And he can set a name for that as well. Anything blurry with this syntax there? I mean, I get it. It can be confusing, that syntax, but let's clarify. Any questions there? I could very much change this code, and I could have said, okay, I'm going to declare a student variable. I'm going to use a student variable, and then I'm going to add that variable to my array. I could do the same thing in a slightly different way. He just went straight, creating new items into each slot of the list.
So this list, students,
Yep.
it's not like a line of information inside, but it's like a table.
You can think of it as a
have
table.
Name, Donald, blah, 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 blah. Another value, like GPA, another one. So this is like 2D table.
Okay. What the way I would like to think of this is that it's a list of complicated stuff, of complicated objects, of complex objects. Because slot 1 has one student there. Oh, but the student has a name, a GPA, a last name, a date of birth. It has a lot of information in that slot, but it's still one slot. For the list, in a way, the list doesn't care about what goes on inside of it. It's just aware that there's one item here, one item there. Then you access that item, and then you can expand and use the properties of that item. But again, and I get it, what you're saying, you can think of it as a two-dimension type of structure. You can think about it like that. You can think of each item as a record. You can even think of each item as a record.
Inside the index 0,
Yep.
it's named Donald. So So name equal Donald. An example.
Okay.
If I add in the list that GPA equal to 3,
Yeah.
for example, I have to assign that to the index 0 also.
Yes.
So I'm going to have then in the index 0, I'm going to have name equal Donald, comma, GPA equal 3, and that's 1.
Yeah. It's not a comma. I mean,
it's just
I get it.
that.
It's that. But both information, GPA 3 and Donald, will be in that slot.
Okay,
Yes.
yeah.
Yes. Both of them. Okay. Okay. Any questions? Let's finish the video here.
And we could even come back up to here, list students bracket 0 dot GPA equals 3.5, and we'll do the same thing here, list students bracket 1, go to the next element, GPA equals 4.0, because Mickey for some reason always did better than Donald, and then we could use our for each. And now you have to specify the data type associated with the list you're going to work with. For each student, we'll call it OSTUD, in the list of students, let's do something with them. Let's print off OSTUD dot get data method. So this says go to the list of student objects, grab the first one, which is a student object, put it into that variable, and let's go call that variable's getDataMethod, which should print off the name and the GPA. I'll go ahead and add a console read line across the screen, and let's see if that actually works. We should have created a list of student objects. Add a student object, access the attributes. Add a student object, access the attributes. Print them all off. And when we run that, we should see the data that we just loaded.
Sorry, black screen. My bad.
So as you can tell, working with a list versus array list, same thing. It's just you specify the data type for list. And that allows us a little more flexibility in our source code because we don't have to go and cast whatever is in each position.
Okay. So again, just a similar process that we have gone through, but our list here originally, there were strings, and that one are students. Let's go for 5 minutes, and we'll be back with more. It guessed. It guessed.
For the test.
What's that? For a test. Mhm.
So it's a good practice. It's going to be open.
Open book.
It's a good practice if we have like individual functions to be ready to apply it. Like to have.
It could be good. I mean, it would be good. Actually, what you're going to be doing Friday and Wednesday and next Friday will be exercise very similar to what will be
So
in
we
the
can
text.
keep all these
You
little
can.
parts,
You can.
like our
just use it.
libraries and then the test.
Of course.
Everything
Of
is-
course. That's the idea. That's what I was hoping for some of the questions of the tests, is that you had done the exercises and you had those code snippets around so you could use in the test. Mona?
Like, how many questions would be in the test? Like, I'm figuring, like, timing and...
Okay.
You know?
So we're not going to be having questions like you're going to answer, in a text format. You're going to have a scenario, and it will be very similar to the exercise that you're going to be going through. But it's similar to the coding exercise that we do. We have a class, oh, so I'm going to implement this class. And this class will need an interface to enter the student name, the student last name. Oh, so I'm going to have to draw a little interface here. Oh, there's a button that when we click, we're going to gather this information from the screen and do something with that information. So it will be like that. It will be very hands-on, computer, Visual Studio, coding. Okay? Yeah.
You went somewhere. Here you have my property.
Oh. Yeah, true.
Because I put in my
Yeah.
in there, and when I went to the author
I don't know
document,
why.
I said,
Maybe
oh,
I
it's not there.
maybe I just looked at through these and
Yeah.
colored there. Why do you have color there? I'm just
Because this is not the same that is here. Look, here it's different.
Oh, I see.
and
it's
I
slightly
took that
different.
one and started to
Okay.
do, and
I'm, yeah,
when
I have
went
to.
to
Yeah, I'll check that. I'll check that and
but
let me see if I need
would
to
not-
fix.
But don't need that, right?
Yeah, I mean, to be honest, if I have been contradictory like that, either way would work. I mean,
Okay,
there's
okay.
there's
No,
no.
because I was looking again all the program and I say, why I
Yeah.
put this? It said
Maybe
don't have anything.
I've changed something there and yeah, I'll have a look and if I need to send a message,
Okay,
I'll send a
I
message.
was a little bit-
Thank you.
It's okay.
That's the second time that you do the first time. No? I think I'll be having US double checking my stuff, you know. Paulo, if you can sign and pass along.
But probably okay.
Okay, so before I move on here, I just want to remind you that Friday, now in 2 days, we're going to be our last quiz, which will cover abstract classes, interfaces, and GUI. Okay, so that's what will be covered in the next and last quiz. Okay. Yeah, wanted to give a quick reminder about that. Anyway. Okay, so just a quick, in a way, a quick summary of when to use a list. When should you use a list? Well, in a list that can have duplication, so your list should, if you are trying, to use in a collection of items that may have duplication, list is a good one. A list will grow automatically. List is also very commonly used. And it is a better alternative to arrays, okay? So again, whenever you're thinking about an array, hey, maybe don't use an array, use a list. And then you're gonna see next another kind of collection as well. When not to use, when you need search efficiency. When you need to do search in your list, you may want to use a dictionary instead. It's another type, it's another collection, and that's what we're going to be discussing next. But before we go there, let's go to Nearpods, and I have a code for you already here handy. So load Nearpod. This is the code. There are, I think, 3 exercises there, 3 or 4. So this is the code on Nearpod. Nearpod. Like here it is. So Nearpod, that's nearpod.com, and the code is this, sec008. Okay, so have a look there in a few questions, and let me just give a few 3 minutes here for us to have a look at that. Sorry, I'm gonna keep the codes open. I'm going to mention this again. On Friday, starting this Friday, you're going to be doing exercises that will be very, very similar to what you're going to be doing in the tests. If I were you, I would not miss that, because you're going to be missing, you're going to be missing the chance to practice very much similar to the test, okay? So again, don't come to me after the test and say, I've never seen this kind of thing before. Well, you may have missed that Friday. And even if you miss, there will be a recording, and again, you can review that, you can recap that. So again, there's no reason why you don't see it, even if you don't come Friday, but I'll be going through. Even if it's just me and the wall, I'll be going through that. Okay, so let's have a look there. So 4 questions. How do you find the size of a list? So again, let me increase this. So again, you use the method count, or the property length, or the property size, or the property count. Which one? D?
No, because it's not a...
So, again, length, I don't know if we have length or size, but we have count. However, count is a property or a method. If we have a look at the code, count has parentheses or not?
No.
So if it does not have parentheses, it means that it is a property, okay? So we're going to be using, so it is a property. How do you declare and create a list of account objects? The same way as he was doing with students, we're going to have account as well. So again, well, we need the less than, greater than, and less than. So again, it's not by using this. What about the second one?
That one. That's good.
Yeah.
What happened?
Actually, to be quite honest, it's none of them because they are all missing something here. What are they missing?
The capital, no.
The object name. They're missing the object name.
Where?
There's no object name. Well, so the intention is that we have a name right here. I did this to catch you, okay? It's not my mistake, okay? Well, so if we had a name here, right, between this, then assuming that we would have one, then which one would be? Would be B. So again, it's a strange syntax, but keep in mind that the list is a class. Classes to be created to create objects. It uses the parentheses. The parentheses means the constructor. We are calling the constructor, so we cannot miss the parentheses, even though this syntax looks a little bit strange. Okay? I have to fix that. I have write a note to self.
If I fail, it's your fault.
And you have proof, no?
Yeah, I know.
If the current capacity of a list is 16, and the list currently has 14 slots filled, if we try to add 3 more slots, 3 more items, what will happen?
D.
B,
D.
D. So let's go top to bottom here. So again, capacity of the list increased by 16, so it doubles. Correct. So again, no error happens. This is not an array. Array, we would have a problem there. But again, the other ones, they are not correct. So yes, D. You cannot have duplicated items in a list. True or false? False. So it is a big false. Great. Awesome. Okay, so now let's talk a little bit about dictionary. Dictionaries. So when we're dealing, so dictionaries is yet another type of collection, but it's in a way it's a more powerful, requires more memory, but it's a more powerful type of list. It's a list that has the format of a key-value pair. Let's see what that means. It means that for each item in our list, there will be a key associated with that item. Again,
Like a dictionary.
yeah, like a table that has an index, that has an ID. Okay, this key, it can be an integer, it can be a string, it can be anything. We're going to be mostly using keys as either numeric keys or string keys. Okay, those will be the most common ones. Let's say we have, that's the exercise that we're going to be doing Friday. We have a list of students. The students have an ID, and a username, a user ID. It's a numeric value. And then I want my application, I want my users to be able to search by user ID, by student ID. So the student ID can be the key, and the value is the actual student. All the student information will become the value. So if I try to go to student 300 and 300,000 and 100, I just put the value, the key, and it finds for me right away. I don't need to loop through. So that's the advantage of using a key pair. Key is the information that you're going to be searching for, searching by. And value is, given a student, I want to return all the information from student 300. The value will be the entire student information. The key will be 300. We're going to see a lot of examples with that. It has a great performance when searched by key. So if you need a collection that you require some sort of indexing capability, searching capability, a dictionary will be more appropriate than a list, okay? However, it cannot have duplicated keys. But again, maybe it's our use case. There's no student ID that is duplicated, so great. It's okay for our use case, okay? And as with lists, it also comes from the namespace system.collections.generic, okay? They come from the same space, both of them, dictionary and list. Here's a quick example. Now, this definition is still stranger than the list, because now we don't have one type only. We have two types. The first one is the key. The second one is the value. So again, in our examples, and usually you're going to see that the first one is usually an integer, a string, is what you want to search by, okay? In the second one, well, in this case here, it's just a string, just the names, but it could be student, it could be account, it could be any complex object that we have worked before, okay? But again, just to get us started, we're just going to create a dictionary which has the key as an integer and the value as string. Again, a little bit more complex, the syntax, but it just added one more type here. So we have a key in a value, key and value, key and value. We have the variable name, we have the new, and we create by calling the dictionary again with the same types and with the parentheses there.
So that those numbers are always going to be associated with that specific name?
Yes, yes. However, you can access items and change them. The same way as you can do that with lists, you can access items and make change to them.
Just one question. Can I have a class there?
You can have a class
If I
here.
have a class that is the number and the name, I can put there a class?
Like students that have a number and a name?
The number and the name, and I just put the class and
Yes.
okay.
Yes. The same way as you saw in the video that he was creating a list from the type students, you can create a dictionary from the type which the value is a student. Okay? You can. And actually that's, I mean, this is a very simple dictionary, but again, you can have more complex dictionaries, as you can see. And as you see, we have an add method, we have a remove method. However, the add here, we have two parameters. We have the index, the key here, the first parameter, and then the value. In our case here, a string is the value. However, again, we could have new students, as he did there with the list. We could have here, instead of John, if this was a student class, we could create here new students. And then but again, so very similar to a list, but we have one more piece of information. We don't have just the values. We have the values and a key that index the values, that you can find values more quickly. That you can just say, hey, give me students 123 there. It will give you right away. You don't have to loop through. You just call it, say, hey, give me this one, and it will give you this one, without you having to loop through. Okay? Here, again, this example, it's adding 4 items to the dictionary, and it's going through a for each loop. Now, what is the difference here? Well, in our for each, it's going to the list, it's going through the list of keys. See, names is the variable. If I put .keys, not .keys. Go ahead.
I don't understand for each why we have to add something. We should be displaying something inside the for each.
Well, this is just adding to, it's a list in the user interface. I'm going to open this sample, and then you're going to see what is that. I mean, this is a list box. So it's a UI control that you can add items to it, and then you can visualize them. It's a list. It's a UI list box. So we're just adding to the list box of keys, the list box of values, and then the list box of keys and values together. The most important thing here is how we are accessing the information. Index is the number here. Is the number, and then if you say names, which is the name of my variable, of my object, names, and then put in brackets the index, this will return this string. So again, we don't have to, we can give the key, and it will return to us the value right away. We don't have to loop through.
So that, what did I say? List keys, list values. Did you make those up, or are those like?
Yeah, those. Let me open this demo application. It will become more clear. Yes, but the short answer is yes. I have made them up here on my example. So this is a dictionary Windows.
This is a case sign version. It looks really better. I saw one.
Again, this demo app is available on the zip file in your week 12 on Centennial. Okay, so let's have a look at this. It's a slightly different example, but the idea is the same. Here, I have a private variable inside our form class, and this dictionary is a simple dictionary that has an integer and a string. The index is an integer. The string is the value, and this is just yet another way that you can initialize a dictionary. You can just add the values right here, right this way. Now, I'm creating a bunch of items in this dictionary all at once I declared it. So again, I'm adding all these items to the dictionary right after I've created it. Okay, so as you can see here, new dictionary, and again, the syntax allows me to add a bunch of items all at once. Okay, now what am I doing with those items? In the form load, which you know that is the first action that happens when we run a Windows form. Okay, I'm just going through a for each loop. Same for each loop that I was going in the sample code. I'm just going go for each number in the numbers keys and show me the number, which is the index, the string associated with it, which is the numbers index, and then it shows me, it converts to string, and it shows me the number again. So let's run this, so you have an idea. Okay, it's and that's so small there. Let me see if I. Okay, I'm gonna try to make this font increase right away, but maybe things will get ugly here. Let's see. Okay. Yeah. Anyway, it will become uglier as I go. Anyway, the idea is that it goes through the keys, it goes through the values, and then it shows the keys, and it's not the keys, okay? So it's the keys. Okay, so again, it's looping. Remember, this is just a simple control. This is just a list box, and I use the items.add to add items to the list box. So again, I'm just using some visual controls to add the list of numbers, the list of keys, the list of values, and then the list of keys with the values as well. So this is the output. So again, we have, now, here's the thing. It's showing in order here, but it's showing in order because we have added the items in order as well. However, if we mix things up here, and let's just do a little mix here. If I run that, you see, the first item, which is item 0, becomes 1. So again, this is not, I'm just trying to prove that this is not ordered. I can change the order that I have added, and the things will get mixed up here. So dictionary, just a dictionary, is not an ordered collection. It's an indexed collection because I can access the items by the index, as I'm doing here. You see, this is the collection name, and this is the index, and this, sorry, we can call it index, you can call it key. I mean, you're gonna hear those words interchangeably used here. Key or index means the same thing. So we are using the index to retrieve the value. Okay, so, and again, I'm just saving some time here. Instead of adding item by item manually, I'm just creating, with using this syntax, I'm creating it right away, all these 10 items there. Any questions? Anything? Okay. Let's move forward here a little bit. Now, in terms of dictionary, this is so far of what we're going to be talking about. I'm more interested in a very particular type of dictionary, which is called a sorted dictionary. Sorted dictionary is a dictionary that, well, behaves very much like a dictionary, but it is sorted by the key. The only two differences as compared to the dictionary. One is, of course, the name. This is called sorted dictionary. The other one is called just dictionary. But the other one is that as we add items to this dictionary, it will change its ordering because it will be sorted by whatever the key is. It will be sorted by the key. Let me demonstrate that. Again, similar to dictionary, but items are ordered by key. Let me go back to our example here. I had this already ready. So I'm going to comment this out, this first dictionary, because I have a second one here that is now a sorted dictionary, very similar, actually the exact same structure. However, can you see that the items are added, but they are all mixed up? See, in the previous one, when I printed out, it prints out in that order, because that was the order that we have added the items to the dictionary. However, on this one, because it is a sorted dictionary, it's sorted by what? By whatever the key is. Our keys are these numbers here. So even though I'm adding them in all kinds of order, not a pre-established order, but when I print them out, they will reorder themselves. See, again, no order there. I'm still using the same code to prove that it's so similar that I can use the same methods, the same structure. So again, they are very similar classes.
You said dictionaries you can't duplicate?
You cannot duplicate. You cannot. Yes, the key, you cannot duplicate the key. You can have only one item with that particular key. You can have two strings called 9, but you cannot have two keys called with the 9 number with the same key. Okay. Actually, we're gonna try in a second here to try to compile this. If we duplicate, let's see what happens. But before we go there, let me run this. See. I've gone through start to finish the sorted dictionary, and you see it comes ordered because it's ordering by the key, the number here. Okay?
Is 8 supposed to say either?
What is that?
8.
It says either.
The name is either no 8.
I have no idea. I mean, I might have been copying and pasting. I don't know why. Okay, let's try to make a duplication here. See what will happen. See, right there. Same key already exists. Again, this is an exception that you could catch that exception, so it doesn't throw like that. Okay. So, any questions? Any questions so far? Again, I mean, when I saw this syntax first time, I thought it was complicated, but again, once we start practicing with that syntax, it becomes hopefully second nature. The same, a similar piece of code, however, this time around again, it will be ordering by the IDs because we're using a sorted dictionary.
Wait,
Very similar one.
so you have sort dictionary there, and then new.
I missed that.
Okay.
Arrow. I have to rewatch this video complete so I can keep
I
fixing.
have a lot of proof, just in case. I said it.
See, the good thing is that the last section of the week is the one that will get without all of those problems, you know, because I fix them as I go through. Anyway, you're right. Yeah, this is missing here. This is supposed to be sorted dictionary, okay? A few properties. We have count as well as we had with items. Sorry, as we had with lists. We have item, which you can put the key inside. You have keys, which is a collection of the keys. Values is the collection of the values in the dictionary, in the sorted dictionary. Sorted or just dictionary, they both have the same kind of properties. In a few methods that we can see there, we have the adds, which we have seen that. We have clear as well. And we have contains value, which returns a true or false. And you have quite a few ones there. Again, just for your reference. I think I have another demo to do here. Sorted Dictionary Windows app. Okay, let's see here. Let's have a look at what this code is doing here. So let me first show the interface. And again, I was not expecting to show in this resolution. Actually, let me see if I can change the resolution here so we can see this slightly better. Okay, great. So here's what this application, this test application, this demo application is doing. I can put a list of words here, separated by space. And what the application will do after I click process list, it will get each word in that list of words, and it will do a count. It will count how many words, items have been in this list here. It will count the numbers. And I will be able to find, by typing the word, I'll be able to find the counts. So let me just demo that. Okay, so this became too big. So I'm just going to copy a few words here, and I'm using the colors. See, so I just put a bunch of names there, colors, and it will, when I click process list, it will count the number of times that we see red, we see green, we see blue and yellow. So here's what we see. Black, so it shows up twice. Blue, green, orange. Red shows up 3 times, and yellow 1. So again, this is our dictionary. Our dictionary has 2 pieces of information. The key, actually different from the other one, the key here is the color. So the key is the color, the number is the value. So we're doing something slightly different here. Color is the key, value, no, the count is the value there. So the idea of this interface is that I can put something like white. And I can click and I can say, no word has been found with white. So it's going through the list. But again, with one single line of code, and I'll show that in a second. However, if I put red, find, see, it returns 3. Because it went through the list, and it found the red, and it returns the value. Let's have a look at the code that goes on behind of this a little bit. Let's explore that. So, let's see. Okay, from a UI standpoint, what we have here is, if I can scroll this. So we just have a text box in the left-hand side, a text box in the right-hand side. So I can read from one, process and show in the next one. We have text boxes here as well. We have a read-only text box here, and we have 2 buttons. Now, what is process list doing? So I have declared as a private field something called word dictionary. It's a private sorted dictionary. The key is a string. The value is an integer. But I just have declared it. I have not created it. So I'm creating, and I could have created there right away. But I've chosen to create during when we click the button. So the process button, the process click here, see, if I go to the events, we have a click. So the first line here, I'm creating the word dictionary. Again, I could have very much created it right here after declaring it, but I just decided to do it like this. Next one, I'm getting the words from the first text box. I'm getting from the text property. Remember, the text property in a text box show you the content of that text box, okay? And then I'm using the split. We have seen split before. I've seen plenty of times. We are using splits. I'm splitting the string that is there, all the words, by space. So whenever it finds a space, it creates a new item in the split. Remember that split will return an array of words, okay? So again, I'm splitting them up. I'm saving the array in the words array. It's an array of strings. And then I'm looping through it. Now let's have a look at what this loop is doing. So I'm just going to go word by word. When I split right here, if I use that text, how many times will red be in this array here? Well, it will be 3 times in this array. So, because again, we are splitting based on this space. So, if I split by space, red will be 3 times, and we know the other ones already. So, now, the loop will go through each word, and I'm just checking, just to make sure if the word is not an empty string. It's different from an empty string. What I'm doing is, I'm just setting the word key to lowercase. See, this method from string will get the word and will put the entire word in lowercase. Okay, so very, very useful for nothing in particular, just to make things a bit more standard. Then, remember, word dictionary is our sorted dictionary, okay? So I'm using a method of our sorted dictionary that is called contains key. So contains key is a boolean, and I'm saying, hey, after it reads the first item in the list, it's checking if the word dictionary already has that color on it. If it does not have, it will add the word to it with the value of 1. So it found 1 red. However, the second time that it goes through the loop and it finds the second red, what will happen is that word dictionary contains red already. So it will return true for the second time. In the second time that it finds a repeated color, now what it will do is it will find the value. So this becomes red. So it's finding in the dictionary, giving that value that comes with this key red. And then it assigns itself again, so 1 plus 1. So it increases by 1. Every time that it finds a repeated color, it increases that position by 1. Just to count. So it's just counting. This is just counting the number of times that particular word has been added to that second box there. Else, it adds 1 because it found 1 of that. And let's stop there for a second. I would assume that there are lots of things confusing there. Come on. Tell me, give me something. I cannot guess what's going on in your heads. I just know that by the puzzled looks, that this is... Come on, give me something here to work with. Come on. One thing that does not make sense. Just give me one thing so I can, maybe try with different words or try in a different way. Come on, Paulo, give me something here.
I understand what you're saying. The problem is I cannot keep 300 things in my head. When I leave this classroom, I'm going to forget half. So I need to practice this. Probably 85.
You can always watch, That's a good thing with this.
Yeah, it's not.
So,
you're using arrays, right? So
yeah, so again, let me mention this again. This looks confusing because maybe, again, you are not being able to map which variable is that one and what is that variable again. Say that again. What is that variable again? Let's forget the code for a second. What I'm trying to do here is, let's just repeat from a high level standpoint. I want to get this list, this text here, whatever it is here. Maybe it's a Word document or a text, whatever it is. Whatever I paste here, this other side will break it down into each and every single word that is here, and it will count how many times that word shows up there. So the first step that I have to do here with this text, I have to break it down. I have to separate the pieces of that text. How do I separate the pieces? Well, I need to separate based on a space. I know that this is a word and this is another one because I see space around them. So I break the string apart based on space, one space. Not an empty space, but a real key space. Okay, so I break it apart. Once I break it apart, my initial array will have red will be the first one, green the second one, blue the third, yellow, red, black, orange, red, and black. So I'm going to have an array like that. Now, I don't want to, just to repeat the same names at the same order that is there right here, I want to count them. I want to count. So I want to collapse. I want to say, okay, so red shows up 3 times. That's the reason why I have to loop through the array. I'm looping because I'm counting. I'm looping to count. Okay? Now, let's go to have a look at the code here again. So, this line, I'm breaking down the string. I'm breaking down into an array called words, array of strings, broken down by empty space. Sorry, not by empty space. A true space. See, this is a... This would be an empty space, which would not make sense, but I'm pressing the bar, the key bar. Okay, so this is, I'm breaking down the string by the spaces. And then, I'm looping through the list. In a way. As I loop through, I will check if red, the first red that it gets, I'll check, is my collection, does my collection already have a red? If no, it goes here. Oh, you don't have red yet? Add a red with number 1. Because again, the value, the value is the counter. Is the counter. Okay, so if I found the first time, I add red 1. I loop again. Oh, I found blue. Oh, blue is not there in the dictionary yet. I'll add blue 1. I go again. I found red again. Oh, red is already here? Great. So, on your value, which is 1, add 1 more. So keep adding. As you find repeated words, keep adding to that existing value. 1, 2, 3, and it keeps growing like that. Okay? And then, at the very end, I'm looping through the dictionary, and I'm adding the dictionary to the other box. That's it. So, again, first, break it down, loop through it, and find the repetition, count the repetition, present it in the other box. Okay? Let me see here. Yeah. Again, we're going to be practicing this. You're gonna, you not only have this copy here, but the exercise will be going through things like this. Which, I get it, it's not very straightforward, and believe me, I do get it. Okay. Okay, so I'm just going to mention this. This is not super relevant, but I want to mention anyway. There are other types of collections. There are many, many types of collections in C#. Many times. I've just covered here 2 of them. Lists and sorted dictionary. A little bit of the dictionary as well, but sorted one, I mean, is the one that we're going to be using. So, again, you have array list. Array list used to be used quite a lot, but it's more of a legacy collection. Legacy, when you see the term legacy, it means that it used to be popular at some point. Now it's no longer popular, but it's still there because older applications might be still requiring that, okay? So it's legacy. It's there, but hey, if you are creating something new, you should not use it. Leave that for the older applications that might be using that already, you know? So again, it's a legacy type of collection. A few other types of collections we have, they have very defined use. You have stack and you have queue. A stack, I don't know if you have seen this before, but in a stack, think about it as a stack. You put one thing on top of the other. So in a stack, what you have is the last item in the stack is the first item that comes out of the stack, okay? Because you stack things on top of each other. The only way that you can reach the bottom one is if you take all of them out of the top one. So again, it has a very defined use case. If you need a stack, hey, you can use a stack. You have a queue as well. Queue, differently from a stack, when you queue things up, the first that goes in is the first that comes out. So it's a line. It's kind of a line. So the first one that comes in, then you have the second, the third. The first one is the one that goes out as well. So we have a first in, first out. In a stack, you have a last in, first out, because you have a last in, first out. What is that? I don't know if you can use things like insert. I don't think so. I think that you have to, there's something called a pop in and pop out. So you pop out in a stack from the top, and then you pop out from a queue from the bottom. So there might be some inserting, but you may have to unstack things. Okay? There's a bit of a practice here. I'm going to save this practice for Friday. I'm just going to wrap things up here with a bit of a summary. As you can see, there are many ways to store collections and store data in C#, collections of data. Again, different ones will have different you use different ones with different goals. If you have search in mind, you use dictionary. If you have order in mind, you can use sorted dictionary. List is a more flexible way to collect data than the array. So again, once you are using now what you used to use arrays for, you may want to choose this time around to use lists instead. Okay. And then we have seen dictionaries, which stores a collection of key value pairs. You're going to hear that quite a lot when you talk about a dictionary. You have key value pairs, key value. So you have a key, an index, and a value. Okay? So that's what, and again, used for certain purpose. If you want your list to be sorted based on a key, you use a sorted dictionary. You're going to be using that a few times here. Same as dictionary, but the data is ordered by key. Okay? Again, that's about it. Don't miss Friday. If you miss, have a look. But we're going to be going through a very detailed exercise. Really, I mean, if you come in, use the time well. Use the time well, because it will be very similar. And it's an extensive exercise, but hey, it will be very useful. What's up?
Is there any way we can, in a text box, the application,
Yep.
we just write the words separated by space, whatever, instead of using array to bring those words to array and whatever, can we do that directly to the list? Like to avoid using array like in the middle?
So, because you have to use split is the method. Split only returns array. However, there might be a quicker way to add an entire array to a list already. There might be a quicker way. So there might be a method in the list that will allow you to add an array. Hey, take this array and add them up. There might be a way. I don't recall on top of my head, but there most likely there's a way to do that. Okay. Awesome. Thank you very much. See you all on Friday. And again, remember, of course you're gonna come. You cannot not come because it's a quiz. Good. Hey, thank you very much. Okay. Yep.
The survey.
What is that?
Survey?
The survey? Yeah.
Just tell them you want.
Yeah.
Receive your email about it.
Yeah. The survey, I mean, there are still 13 people without the survey done. Please, 13 people, get it done.
Anderson, you have
13.
time to explain something here?
Sure. Carl, let me just spec so the other professor can get coming. Let me just spec and I will stop by.
No, I will take a picture and I ask you.
Sure?
Yeah, sure.
Let me see. Let me see if I can help you right there.
Here, I don't understand. Okay, this is the line.
Yes.
But how he knows which is the word key and which is the number here? Because you were...
Let me tell you something. So, word dictionary is the entire dictionary, correct?
Yes.
This is the key. The
Okay.
key is red. Red is a key.
Okay.
So if I say word dictionary red, it will return a number because it's not here anymore.
Okay.
See, it will return the value. The value is an integer. So the value is the counter.
Okay. Okay.
The value. So
Okay.
this thing here is this. So I'm saying that get the counter, which if it's the second time, it will be 1. Get the counter, which is 1, add 1,
Okay.
and set it and make it
No,
to be the new
okay.
value. So it keeps adding 1 to itself. Every time that it finds red, it adds another 1.
Okay.
So 2, 3. But again, remember that this will return the value. This whole thing here returns the
Return
value.
not the,
No,
not
no,
the-
no.
never
This,
just
the key is this. The
key
string
is
is
just
this
that.
one here.
Okay.
Okay? Because we're indexing by the string, by the
Okay.
red, green.
No, I
Okay? And the
understand.
counter is the value. Okay?